Assalamu alaikum. Hello everybody. This is the third lecture in the course of Fundamental of Soil Science. This lecture will focus on the double layer and the absorption phenomena to the soil particle and the ion exchange on the surface of the soil particle. I would like to continue last part of the lecture number 2, which was about the application of electric double layer. I told you that we have three factors affecting the electric double layer thickness. The first factor is the concentration of the counter ion. As you know, that the higher concentration of the counter ion or electrolyte on soil solution led to the less thickness of electric double layer and vice versa. As I told you on this graph, that the low concentration led to dispersion of the counter ion around the soil particle, consequently increase the electric double layer. The same for the valence. The higher the valence, the lower electric double layer. Then we have two factors now. The third factor is the first is concentration, electric charge of electron or valence, and the last one is the hydrated ion radius. The higher the higher the hydrated radius, the higher electric double layer. If you have a higher electric double layer, hydrodynamic diameter, or hydrodynamic or hydrated ion radius, the thickness of electric double layer increases. So if the thickness double layer increases by increasing the hydrated ion radius. If you look here, I think this part was not clear in previous lecture due to limited time. Now I will explain more deeply this part. I would like to know that we have two type of ion radius. The ion radius and hydrated ion radius. The ion radius is the radius of ion only, but on water solution, the ion absorb some molecule of water, a film of molecule of water, and the lower diameter absorb more ion films or ion molecule than higher diameter. As you see here, the lithium has a lower diameter than sodium, and sodium lower than potassium, and so on. However, here we are talking about ion radius. But if you are talking about hydrated ion radius, you will find that the bigger hydrated ion radius is lithium, and then sodium, then potassium, and so on. So now when we are talking, if you are talking about the ion radius here, so the ion radius, the lower ion radius, the higher electric double layer. However, if you are talking about hydrated ion radius, the higher ion radius, the higher electric double layer. Okay, is this clear for you? So now I'm talking about ion radius here, the distance here. So if you are talking about the hydrated ion radius, means that the radius of ion plus the water molecule around of the ions. As you know that the water is a dipolar. What we are meant by the dipolar, we are mean by dipolar that the water is H2O. There is O here minus and H positive. Each pole has a charge differ from the other pole. So here is the negative charge is dominant. However, here there is the positive charge. Due to lithium has a positive charge, the water molecule directed the ball contains negative charge to absorb around the lithium ion and absorb many films of lithium around the ions. This called a hydrated ion radius. If you have a hydrated ion radius, look, due to potassium has a bigger size than lithium, the ion radius is bigger than lithium. Its ability to absorb, to bond ion water molecule around the ion is less than lithium. So if you have a higher or a bigger hydrated ion radius, then you will have a bigger electric double layer. The thickness of double layer increases by increasing the hydrated ion radius or by increasing hydrodynamic ion diameters. Okay, so here you can observe that the ion radius is low. However, hydrated ion radius is high, and vice versa for others. Here, increasing the ion radius, however, decreasing the hydrated ion radius. The hydrated ion radius is defined as a radius of ion and plus closely bound water molecule. The ion with bigger size and low charge hold water molecule less tightly and thus have a smaller atomic radius. So the ion with bigger size and low charge hold water molecule less tightly and then have smaller atomic radius. So I think now it is clear for you now that the ion with bigger size hold water molecule more than less than, thus have smaller atomic radius. Okay, so it is clear that the electric double has been affected by the ion concentration. The lower the thickness of double layer decrease by increasing the ion concentration, ion valence. The thickness of double layer decrease according to the valence of cation as following. Monovalent cation has more thick double layer than divalent. The compaction of double layer is occur with increasing uh, with increasing the valence, the uh, valence, the ion concentration, and by increasing the thickness of double layer also actually increase by increasing hydrodynamic diameters. Okay, here is the thickness of double layer increasing by increased hydrated ion radius or hydrodynamic diameter. So the electric double layer is increased by increasing the decrease by increasing the valence, and the decrease by and ion concentration, while increase by increasing hydrodynamic diameter. So the electric double layer thickness increase by increasing valence concentration, while decrease by increasing while increase by increasing the hydrodynamic diameters. The first two factors, concentration and charge, its increase decrease electric double layer, while the hydrodynamic diameter or hydrated ion radius increase led to an increasing of electric double layer. So now we will go to a new topic. This a new topic and phenomena usually occur in soil. These called adsorption phenomena. I think you studied adsorption for different in different courses. Here we are talking about the adsorption processes in soil, on soil particles. The adsorption is defined as the accumulation of material, not necessary to be ions, maybe compound, molecule, and so on, organic or inorganic, pesticide, organic acids, and so on. So the adsorption is defined as accumulation of material on the layer between the solid surface and the liquid. Adsorption in general includes the following process. The first is removal of solution molecule, solute dissolved in solvent, solute material dissolved in a liquid called a solvent. The second step is removal of solvent from the surface of the particle. The third is the bending of solution molecule to the surface, which means that the adsorption is occur. Adsorption does not include surface precipitation. To the surface precipitation on the particle, if there is a precipitation like carbonate and calcium carbonate on the surface, it's not also not include polymerization. So there is another sorption. Sorption is not adsorption. another expression called sorption. This sorption is mean that